I'm very excited to be here today. 4 years ago, when Macintosh was first introduced, it would have been a bold prediction to say that Apple would ever participate in a major Unix conference. At the time, the Unix system was well established as an excellent choice for users who needed powerful and complex computer systems, and Macintosh, on the other hand, appealed to a less specialized group, those who may have been interested in the technology, but were just as likely to be mystified and intimidated by it. The Unix system and the Macintosh seem to occupy very different worlds. But today, I want to share with you a perspective that I believe is of major significance for the Unix community as well as for Apple. Now, something has happened over the last 4 years. As we near the 1990s, we are seeing the old divisions breaking down. Computing environments that were once separated by technology or ideology are beginning to converge. The power user and the average user are beginning to realize that they have more in common. The average computer user is beginning to crave more power and capability, and the power user is becoming aware of issues of usability. Now that we've been living with personal computers for more than a decade, we're beginning to understand their impact on people and organizations. Computers are now a permanent part of the landscape. At Apple, the application of our own technology has transformed our organization. Now, what you see when you visit our offices is a Macintosh on every desk. But more importantly, they are all connected to local networks that share printing, file service, and other resources, to global electronic mail systems linking all Apple offices, manufacturing sites, and distribution centers, as well as key customers, developers, and vendors, and to many computers and mainframes in 16 worldwide data centers. Now, all of us rely on Apple's technology to do our jobs, from our security guards who use Macintosh to connect into databases of company property, to finance people calculating expenditures and income, to personnel managers who access employee information from databases on a VAX. Even our design engineers use Macintosh as a front end to our Cray computer. Now, if we can't rely on our own technology, how can we expect anyone else to? But we found that a personal computer is an even more powerful tool for the individual when it can effectively connect up to a host mainframes or other personal computers, even if they aren't our own. This ability to communicate and connect is something we'll need more and more as we move towards the 21st century. The pressures of rapid change, the compression of time to make decisions, and the cost to process transactions are making it increasingly necessary to have flexible and accessible tools for managing information. Industry, government, and education all face the challenge of remaining competitive in this fast-moving world. And in order to succeed in this environment, our businesses and education systems must be designed to foster innovation. Yet innovation doesn't come through bureaucracy and hierarchy. It comes from individuals. And we believe, therefore, that empowering individuals will be the key to successful organizations in the future. Now, our goal has always been to create products that empower individuals to do their best work by letting them manage and control the information they require to do their jobs. That means that as computing technology becomes more pervasive and more powerful, computers must become more accessible to the people who rely on them. As this conference attests, the Unix system is in a stronger position than ever before. It is an established standard that many vendors support, and it provides capabilities today that other systems are only just beginning to deliver, for multitasking, for writing large applications that take advantage of virtual memory, and for combining resources from different vendors into powerful networks. The Unix system has been put to good use by networks in universities, in government, and engineering research. But we believe that the single biggest step towards broadening the potential of the Unix system is to make it more usable. And we believe that our experience in personal computing can help. We've learned there are a lot of professionals who need the performance and functionality of powerful workstations, but are still intimidated by them. For them, the Unix system may seem like a power tool with handles too big to grasp, a great automobile with an incomprehensible dashboard. But it isn't just a concern of those who are technically naive. Even engineers and users who are not intimidated by the Unix system are discovering that an intuitive and interactive interface enhances their work. I believe there is a simple reason for that. The more demanding our tasks become, the more we need to focus on the work rather than on managing and deciphering our systems. A personal computer is more than a combination of hardware and software. It's a personal computer, not simply a calculating machine or a transaction processor or a data retrieval system, but a tool designed to engage and empower the individual. The value of a great tool is not in the tool itself. It's what we can accomplish with the tool. Now, I'd like to give you a glimpse of how we've used that principle in designing Macintosh and let you hear from some of the people who are working on future generations of the technology.
Pencils are such simple tools, we take them for granted. Yet they permit us to do things that their makers could never have foreseen. The simplicity and usefulness of the pencil makes it about the nearest thing to an ideal tool that we know.
The ideal tool would be one that was invisible, where the person feels they're working on the task, not using the tool. There shouldn't be something in between you and the task. There shouldn't be a tool that gets in your way. There should be the task.
To keep the tool out of the way of the task, Macintosh uses a see-and-point approach. Apple's now familiar desktop metaphor allows you to work in ways that are far more natural than the structured pathways demanded by earlier systems. It uses icons, files, folders, and pictures to represent documents, applications, and the tools used with them. And it lends itself well to direct object manipulation. It's an illusion, of course, but it behaves realistically, so that our intentions, whatever they may be, are easily translated into actions. The foundation of this approach was set at Xerox's Palo Alto Research Center.
A lot of the ideas that we see today in graphical user interfaces originated at Xerox PARC. What happened was there was an opportunity for people there to bring together technologies that were just emerging from research.
There are lots of people that worked on this, and a considerable number of them came from PARC and joined Apple. And they joined Apple because Apple had taken over and, if anything, was even more enthusiastic about these ideas than Xerox had been.
Once you learn how to use a pencil, you can transfer that skill to other tools, tools that are specifically designed to work like pencils. The principles are the same. This consistency is what allows you to build on experience, to transfer skills from one tool to the next.
Consistency turns out to be more important than almost anything else. If it's the same set of commands I use to type, to erase, to modify, to change, to draw, for all programs, then I'm far ahead. I only have to learn it once.
The basic techniques that the user develops on the Macintosh are applicable to every program the user picks up. It's called leveraged learning. It means that once you've learned something, you can use that to learn the next thing on the next program and so forth. It's consistency. It's the most vital part of any human interface.
To help developers write consistent applications, Apple has formulated and published a set of human interface design guidelines, not strict rules that inhibit innovation, but principles that apply the discoveries of cognitive science to the design of interactive systems. Standard interface features like windows and menus are built into the Macintosh toolbox to be called on by any program. Apple provides technical assistance to developers to help assure the consistency that Macintosh users have come to expect, and development tools like Mac App that contain ready-to-use software code that provides the basic object-oriented interface structure for new applications.
It's sort of like having, 4 of Apple's best engineers on your design team.
Macintosh users look forward to learning new applications that build on our standard principles of interface design. Direct manipulation. To give you a sense that you are in charge, you act directly and see the results. See and point, relying on recognition rather than recall. Why should you have to remember the things that the computer already knows? What you see is what you get. A faithful screen representation of the printed document. No abstract print commands to create it, and no surprises when you print it. Consistency across applications, enabling you to apply what you know about one application to another, reducing learning time and increasing productivity. Transparency, the sense that you are working on the task directly, not manipulating cumbersome tools. And real-world metaphors, allowing you to apply what you already know to the computer environment.
When we did the Macintosh, it seems strange to the public that we had put so much attention into the user interface and the bitmap and the mouse. What we were doing, though, was anticipating what people were going to be needing later in the decade to support the types of graphical applications and desktop publishing kinds of things that we could see coming.
The benefits of this approach are now well established. We've learned that when you make a tool that's both useful and usable, then people actually use it. And we've learned that when the basic principles and style of an interface are established and stable, then developers can concentrate their efforts on meaningful innovation. They can push forward into new territory, knowing that their applications retain enough familiar appeal to be easily adopted by a wide audience.
Now, after 4 years of Macintosh, we've seen a double springboard effect. First, the Macintosh has unleashed tremendous creativity on the part of developers. The consistency and stability of the interface allows developers to spend more time designing innovative applications, not redesigning the interface. And second, new applications are creating another wave of creativity and productivity at the user level. Again, because of the consistency in applications, users don't have to spend a lot of time training in order to be productive. There now exists a large and growing community of designers, programmers, and customers who are fluent with the conventions of Macintosh and work with it easily and successfully. But the momentum we're seeing today was a long time in coming. As Alan Kay and Larry Tesler pointed out in the video, many of the technologies present in the Macintosh existed even before Apple was founded as a company. In fact, many of them also predate Xerox PARC. They had their beginnings in university laboratories and the ARPANET. If you look back to the early 60s at Ivan Sutherland's Sketchpad, you can see the roots of our conventions for drawing on screens. But it was 20 years from Sketchpad to Macintosh. And if you look back to the mid-60s at Doug Engelbart's NLS, or online system, you can find the origin of the mouse. But it was 15 years from NLS to Macintosh. And if you look back to the early 70s at what Alan Kay, Adele Goldberg, Dan Ingalls, and others accomplished in developing Smalltalk, you can find early versions of Windows, menus, and bitmap graphics. And yet it was more than 10 years from Smalltalk to Macintosh. And if you examine these early research projects carefully, you'll find many attractive features and capabilities that are still waiting to be developed. Now, there seems to be an incubation period that averages about 15 years before advanced research can mature into commercial technology and find its way into the marketplace. It seems to take that long, whether the engineering is difficult or relatively simple. The things that we know we want, like great flat panel displays, take a long time to develop. And things which are relatively quick to engineer, like the mouse, take a long time before we recognize that we want them. Well, if that 15-year time span continues to hold true, we can look into advanced technology laboratories today for a glimpse of the kind of computer products we'll be seeing early in the 21st century. I wrote a book last year called Odyssey, in which I described what I thought the personal computer might resemble at the turn of the century. And I called this personal computer the Knowledge Navigator. Now, here are some of the technologies that are crucial to the Knowledge Navigator vision. First is advanced communications. Today, we're constrained by narrow information channels, and the protocols and standards for transferring data between systems is fragmented. We need technology that will link processors and databases anywhere in the world, and that means better vehicles and broader information pathways. The second is graphic simulations. As our computers gain more processing power, we'll rely more on graphic simulations to give us vivid representations of abstract relationships. And as the technology advances, real-time 3D color animation will become commonplace, allowing scientists to visualize complex numerical models with the same ease with which we now graph a column on a spreadsheet. Third is object-oriented distributed databases. Improved database technology is the key to creating intuitive and responsive information systems. One approach that shows great promise in the early research involves mapping and storing information into object-oriented structures. Fourth is hypermedia. Computer visionary Ted Nelson has been promoting the concept of hypermedia for almost 3 decades. But only recently have commercial implementations appeared on the market, with Apple's HyperCard, Owl's Guide, and others. In broad terms, hypermedia is the delivery of information in forms that correspond to the natural patterns of human thought. See, it allows you to make instant choices about where you want to go next. It will give us a much more intuitive way of navigating through enormous collections of information, combining text, graphics, sound, and motion. And fifth, artificial intelligence. This technology is critical to our future vision of personal computing. Artificial intelligence will allow us to create agents that can recognize and anticipate our strategies and preferences and increase our productivity. Well, to understand how these technologies can work together, it helps to see them in action. So I began to wonder, could we simulate the experience of what it will be like to use the Knowledge Navigator?
You have 3 messages. Your graduate research team in Guatemala, just checking in. Robert Jordan, a second semester junior, requesting a second extension on his term paper. And your mother reminding you about your father.
Surprise birthday party next Sunday.
Today you have a faculty lunch at 12 o'clock. You need to take Kathy to the airport by 2. You have a lecture at 4:15 on deforestation in the Amazon rainforest.
Right. Let me see the lecture notes from last semester. No, that's not enough. I need to review more recent literature. Pull up all the new articles I haven't read yet.
Journal articles only?
Fine.
Your friend Jill Gilbert has published an article about deforestation in the Amazon and its effects on rainfall in the sub-Sahara. It also covers drought's effect on food production in Africa and increasing imports of food.
Contact Jill.
I'm sorry, she's not available right now. I left a message that you had called.
Okay. Let's see. There's an article about 5 years ago, Dr. Flemson or something. He really disagreed with the direction of Jill's research.
John Fleming of Uppsala University. He published in the Journal of Earth Science of July 20 of 2006.
Yes, that's it. He was challenging Jill's projection of the amount of carbon dioxide being released to the atmosphere through deforestation. I'd like to recheck his figures.
Here is the rate of deforestation he predicted.
And what happened? He was really off. Give me the university research network. Show only universities with geography nodes. Show Brazil. Copy the last 30 years at this location at 1 month intervals.
Excuse me, Jill Gilbert is calling back.
Great. Put her through.
Hi, Mike. What's up?
Jill, thanks for getting back to me. Well, I guess that new grant of yours hasn't dampened your literary abilities. Rumor has it that you've just put out the definitive article on deforestation.
Aha. Is this one of your typical last-minute panics for lecture material?
No. That's not until,
4:15.
Well, it's about the effects that reducing the size of the Amazon rainforest can have outside of Brazil. I was wondering, it's not really necessary, but,
Yes?
It would be great if you were available to make a few comments. Nothing formal. After my talk, you would come up on the big screen, discuss your article, and then answer some questions from the class.
And bail you out again? Well, I think I could squeeze that in. You know, I have a simulation that shows the spread of the Sahara over the last 20 years. Here, let me show you.
Nice. Very nice. I've got some maps of the Amazon area during the same time. Let's put these together.
Great. I'd like to have a copy of that for myself.
What happens if we bring down the logging rate to 100,000 acres per year? Interesting. I can definitely use this. Thanks for your time, Jill. I really appreciate it.
No problem. But next time I'm in Berkeley, you're buying the dinner.
Dinner, right.
See ya, 4:15.
Bye-bye.
While you were busy, your mother called again to remind you to pick up the birthday cake.
Fine. Print this article before I go.
Now printing.
Okay, I'm going to lunch now. If Kathy calls, tell her I'll be there at 2 o'clock. Also, find out if I can set up a meeting tomorrow morning with, Tom Lee.
Enjoy your lunch. Hello, Professor Bradford is away at the moment. Would you like to leave a message?
Michael, this is your mother. I know that you're there. I'm just calling to remind you to call your sister and pick up.
Now, we think the combination of Apple's intuitive and accessible interface and the power of the Unix system can be revolutionary. This is our first release of AUX, but as we continue to expand our Macintosh technology, we will expand the potential for AUX with tools like HyperCard for AUX and other applications and data management solutions. We want the Unix system to remain an open standard platform on top of which we and others can add distinctive innovation. Now, this is only the beginning of what the market can expect from Apple with the Unix system. We're off to a good start, and we're anxious to see others use our new tools. The power of the computer is not simply with the silicon. It lies in the ability to weave a new fabric of connections between people and knowledge. That's why people who have begun to experience what personal computers can do, even on a limited standalone basis, yearn to extend that experience to encompass even greater capabilities. That's why Apple's customers have urged us to provide greater pathways to connect into alternative computing environments. The computer is a simulation engine capable of encompassing all the categories of tools previously created by man. It has the power to extend the reach of individuals by providing information and allowing them to apply their own insights to it. But we at Apple are dedicated to the continuing refinement of our technology in human interface, networking, communications, and sophisticated applications. And we will rely on standards that allow opportunities for innovation. The Unix system is such a standard. Until today, the contributions of the Unix community and those of the Macintosh community have developed in isolation from each other. Working separately, each of us has been able to define and consolidate our own strengths. Working separately, we've each made an impact on the course of computing technology in the information age. Well, now we need to look to each other to enhance that technology, to realize the potential we have as individuals and as organizations to extend the usability of the technology. We've each been a part of crafting for the information age. And now we have the opportunity together to craft the future. Thank you very much.